knights 2. Okay, so the problem statement is like that the knight is placed on the first block of an empty board. So input will be the size of the board. That is, right now I've taken 6x6 chessboard. It can be any size. So the knight is placed in the first block of this empty board and will move according to the rules of chess. Like it will move to this position, it can move to this position. Okay, just like the rules of chess. We must have to be ensured that this knight should visit in each cell exactly once. Okay, in each square exactly once. So the output will be like the path followed by the knight to cover all the cells. So there are 6x6 chessboard size, therefore 36 cells are available. So we need to find the path which this knight will be following to cover all the squares in this empty board. Okay, so in order to ensure that this knight is visiting each square exactly once, we will be using move number. Okay, move number or step number. Like consider at this position the move number is 0. Now the knight moves in this position and the move number in this position is 1. From this, the knight to this position, it can move to this position. Okay, so from this, suppose it moves to this position, so the number will be 2, move number will be 2. By this move number, we can ensure that each knight is visiting the square exactly once. So this is the problem statement. I hope you got it. So knight will start from this position, from the first square of this empty board, and can move like the rules, like the rules of chess. Okay, can move to this square, and so on. So suppose the knight is in this position. So for the knight, there are 8 choices. Like it can move to this location. So there are total 8 choices each knight can have for the valid move. Okay, so see in this diagram, see this is the knight, and this knight is having 8 choices available for it to move. Okay, suppose knight moved in this, so the move number gets changed. Like for example, the knight starts from the move number 0. Now it moved to this location, so move number changes to 1. From this place, the knight can move to this location, or total 8 directions are there. Suppose the knight moves to this location, so move number become 2. Like this, the task is to find the path followed by the knight, covering all the squares with the move number that represents that each square visited exactly once. So right now we'll be discussing the recursive flow. So we will start from this first square. So the move number will be 0. Now from this we can move to 8 directions, like in this, there, diagonally, down. Okay, so we can move to 8 directions. So as we know that this knight's tour can be solved by using backtracking algorithm. So in backtracking algorithm, there are choices available. That's why it's an recursive in nature. Like this knight is having 8 choices. So at each choice, some decisions needs to be made in order to move, in order to complete this solution. And there is a constraint available. So like this knight cannot move in this direction, cannot move in this direction, in above direction. So these are the constraints which we have to maintain in our code. So from this position, the knight can move, say, here. So it will be 1. From this position also 8 choices are available. So at each square, 8 choices are available for the knight to traverse. From this, suppose knight moves to this square. So the move number is 2. Okay. Suppose we have completed the move number in this position, like in this position, in this one and this one. So we have filled this square, suppose. So from this position, now the knight cannot make any movement as because this square is already visited. Okay, I've already told that move number represents that the square should be visited exactly once. So suppose this square has visited. Now from this position, the knight is trying to make choice. So suppose knight went in this position, it finds that this square is already visited. So this is the constant. This is also a constant, like it is already visited. So it will come here and it will make the movement in different direction. Again, this is already visited. It will again come here. So like this, all the choices are visited from this position. So right now, at this position, there will be backtrack. Like it will move to the collar of this square. Suppose we came in this square, the knight came in this square from this point, from this square. So it will move, it will do backtrack to the collar of this position. And again from this, it will start searching for the next safe choice. Okay, next safe movement. So this is a recursive. By this way, we can solve this knight tour problem. So the base case, if we see the base case, it will be like if the move number equals to uh, size of this board, like the program will terminate when we have completed this whole board, like we have filled this whole board with the step number or the move number. So this will be the base case. If yes, then we will return the true. Okay, we will return true. Now considering the safe function, in safe function we'll write that if the position is out of the board, okay, out of the board position, and the cell is already visited. Okay, the cell ij is already visited. So in this case, this is not a safe movement for this knight. So initially the board is being filled with suppose -1. If this is the safe choice for the knight, then it will be turning to the step number for that knight. Okay, so like this way we can have the account for the squares visited exactly once. Yeah, so considering the time complexity, if we see the time complexity, there are like there are eight choices available for the knight. Okay, it can go up, diagonally left, diagonally right. Okay, and needs to complete this whole chessboard. So 8 to the power n square, where your n is the size of the board, and size of the board is 6. Okay, so this is a time complexity. All like backtracking algorithm are very slow, like it takes exponential time. Okay, so now I'll be discussing about code snippet. I have solved two problems, that is n queen and sudoku, where I have been using this same code format in order to make the program organized. Okay, so we have our main function, and inside this a solve user defined function is there, and in this solve as an argument I am passing the details, like the information. So the information will be the starting position of the board. Okay, mm, empty board in which the initial value should be -1 for all the squares available. And as we know that it will start from the beginning of this empty board, so by default, like initially I've assigned this beginning as 0. This 0 indicates the move number. So I'll pass the next move number, that is 1. Yeah, so this is the value which I'm going to pass in this solve function. Now it will go here, the function will go there and starts executing this. So as solve function is recursive because there are choices available, like there are 8 choices, and in each choice some decision needs to be taken by the knight. So there will be the base case. The base case is like if the knight moves or complete its path, like if the move number equals to the size square, then we can say, yeah, that this knight has completed its movement. Now coming to the choices, there are 8 choices available. So we can represent the direction either by using recursive approach or iterating approach. Okay, so I'll be discussing about how we can represent the direction in our code. Now there are 8 choices available. So before filling the move number in the cell, we'll check, we'll call for the save function to check whether it is safe or whether putting this value in that square is leading to a solution. So this will return true or false. So it will check that the knight must not go outside the board, or the knight must not uh, move to the already visited cell. So this type of constraints we are going to write in our save function. So suppose like yes, save returns true. Now we'll put the move number in the position and again recur for the next empty cell. Again recur for the next empty cell. And if suppose this next empty cell leads to a solution, then yes, it will return true. Means it will return true to this color of that square. So every time the color of the square will be this solve function, as this is a recursive function. Okay, so suppose there are no choices available. So if no choices are available, then this for loop will not be executed. Like it will not execute, and the control will move to this return false. Okay, so if it moves to this return false, for example, consider this square and there are no choices available, like knight cannot move in 8 direction as because it's already occupied by some move number. So from this, the control will move to the collar. The collar of the square will be some position. So it will move to the collar, and what it will do, it will change the move number of the collar to the initial value. Okay, and starts making the choices available to this caller. Means resume the iteration. It will resume the choices. Okay, so suppose the choice was this, but in this part there are no choices available for the knight. So it will move to the caller. Then after moving to the caller, it will find some different directions where the movement is safe. So it will go at that point. So this is a recursive flow which we are going to use in our